Now, what I want to do now, listen please, is to combine Boyle's and Charles' law. We're going to combine Boyle's and Charles' law, and we have this special fancy Latin term for this called the combined gas law. No, it's not Latin. No, it's not clever either. You're right. But I thought the joke was rather clever. You know. So P1, V1 over T1 this time. So we've got all the variables there. Okay? Equals P2, V2 over T2. I know, it was a sad joke. But anyway. Alright? So this actually works. Okay?
Oh my God, that was so ugly.
Alright, now you get to practice now with a learning partner. But now that means if you're going to have a learning partner, it means both of you have to actually do the work. Alright, y'all need to talk less and write more so you can get a fast start. Excuse me. Oh, yes. Oh, yes. Good for you. This is actually a pressure unit here. It's called millimeters of mercury. Nope. Mercury's a liquid. Give me a minute and I'll explain that. Oh, more the volume B is what I should have written here. Alright, so listen up a minute. The reason it's called millimeters of mercury is because in the device that you measure the pressure with, there are millimeter markings on there, and the mercury, liquid mercury, rises inside the device in millimeters, and it's a way of measuring pressure. Yep, exactly right. Okay. All right. So there's your problem. Please solve this problem. Okay, it's the same process. Write your list of knowns and unknowns. Find the right equation that fits that list, because you have your variables, the symbols written out to the left of it. Plug in what you know. Solve for what you don't. Okay? All right. So you're doing a good job getting all your list of knowns and unknowns here, choosing the right equation. But some of you are getting stuck here, so let me show you how to get through this, okay? First of all, I felt bad about my sloppy graph over here, so I redrew this, okay? An inverse relationship on a Cartesian plane looks more like that than what I had before. Anyway, so that's just an aside. All right, let's make our list of knowns and unknowns. 47.5 liters, that's a volume. So V1, 47.5 liters. Temperature, it says I've got 15.0 degrees C. I can't use temperature in degrees C. So 15.0 degrees C plus 273.15. And that's the Kelvin temperature. We're going to round that off because we got this empty slot above the 5. And so I get 288.2 K. So temperature 1 is actually going to be listed as, it's actually going to be listed as 288.2 K. And then we've got a pressure, 650.0 millimeters of mercury. There are about 4 different pressure units you might be exposed to in this class, especially in this unit. I'll show you those in a few minutes. And then we got the pressure change, temperature and pressure changed. So temperature 2 is 25 degrees C, but again we have to change that to Kelvin. Again, we've got this empty slot here, so this 5 over here is going to be rounded off. And so our temperature 2 is 298.2 K. The pressure is 750 millimeters of mercury. And it says, what will the volume be? Well, the volume then is our unknown. Okay, so we know everything but V2. And if we look for an equation that fits this list of knowns and unknowns we have over here, it's this equation. So we're going to write out that equation. P1 V1 over T sub C sub 1 equals P2 V2 over T sub 2. So let me fix that. I don't know why I wrote T2 down here. Then we're going to plug in what we have. We have P1, that's 650.0 millimeters of mercury, right here. Volume we know is 47.5 liters. And the temperature 1 we know as 288.2 Kelvin. On the other side of the equality statement, P2 is 750.0 millimeters of mercury times V2, which is what we don't know, so we're going to leave that V2, and then over the temperature of 298.2 Kelvin. So, all right. So what we want to do now is to get V2 by itself. You could do a lot of math to get there. The easy thing, we want to divide by this and multiply by this so that we can cancel them out. So I'm going to put this on the bottom of this fraction. Put this on the top of this fraction. Okay? So we're dividing by this, which is what we did when we did Boyle's law. We're multiplying by this, which is what we did with Charles' law. Okay? Well, if I do it to this side, I've got to do it over here too. All right. Let's cancel everything we can cancel. Look over here on this side. What can we cancel? This whole thing is the same as that. That whole thing can cancel. This whole thing is the same as that. That can cancel. We've isolated V2. We've got it by itself. Over here, what can we cancel? Millimeters of mercury can cancel, and K can cancel. Okay? We have volume by itself, liters by itself, and liters measures volume, we've probably set everything up right. So now we just multiply this, hit enter or equals on your calculator, divide by this, hit enter or equals again, then divide by this, and then hit enter or equals again, okay? You've got to follow all those steps once you learn to do it. If you're careful about it, this is the fastest way I know of to get an answer. So 298.2 times 650.0 times 47.5, enter, divided by 750.0, enter, then divided by 288.2, and that's the answer you get. Let's see, we've got liters left, so that's our V2. But we need to round it off. That's fine. That's okay. Your calculator didn't give you as many digits. Okay? I just got a more expensive calculator. You know? I mean, I'm the teacher, right? You know? All right. Now, this is a really nice calculator. The math department's using these. This looks a little different, but this is basically the TI Inspire. Really nice calculator, color screen and all that. But not that I'm trying to sell this calculator to anybody, all right? Yes. All right, so looking at all our numbers over here, all our measured and calculated numbers, this one has the least digits. 3 digits. I want 3 digits as my answer. Round it off, and I get 42.6 liters equals V2. Yay. Hooray, hooray. All right. How'd you do? Good? Good. Close?
41.
Yeah, you probably hit a button wrong. Always do your maths at least twice. All right? If you're sitting around waiting, check your math. All right? If you on a test, you might want to do it. If you're in a hurry, short on time, you do it once, but go back and check it if you still have time in the class period. Got it? Wise use of time. Wise use of time. Now, before we go on to the next set of problems, let me point out something to you. If you have out your test references, find the page that we've been using for solubility rules and activity series. Get out your test references and find the page where you deal with solubility rules and the activity series of metals and activity series of halogens. Because there's something really cool on the other side of the page. How about that? Well, how about that? Yeah, well, we don't really care about Dolman High right now. We care about this stuff right here. All right, look at this. Look at here. What I got right here.
Wait a minute.
Oh, wait a minute.
Are you joking with me right now?
He's not joking.
You're not joking, are you?
No, it's right there on the test references. Now look, why did I not tell you up to now? Because I want you to know it well enough to know what to look for, okay? I want you to be familiar with it before you start depending on the test references. You got it?
I see an arrow.
But let's say you get stuck somewhere and you go look on the test references. There it is for you. Got it? All right. There's Charles' law above my thumb. That's the combined gas law right there. It's just got volume and pressure flipped around from the way we used it. There's Boyle's law. How about that? Got it? Nah, not really. Okay? The question was, does it matter whether volume or pressure comes first? Doesn't matter. Okay? And this is the one we're going to do next, the one that's above my thumb now. Tiny n, yes, it's a little n. All right. Let me stop. Capture.